my name is Alexander Kaplitz, and I'm going to be presenting on the analysis of plastic waste pyrolysis oils via two-dimensional SFC by GCVUV. Currently, two major environmental concerns that we face as a society is the buildup of plastic and the continued use of fossil fuels. Plastics are being produced at a rate much greater than they're being recycled, causing them to accumulate in landfills, enter the waterways, and these can then have ecological effects through the phenomenon of microplastics. Fossil fuels, as we all know, are creating greenhouse gases, which is contributing to global warming. One technique that is being developed to try to tackle both of these issues is creating oils from single-use plastic waste. These oils are created through pyrolysis, and pyrolysis is when you use heat without oxygen to degrade matter. These oils that are created from these plastic wastes, like the plastic wrappers from candy, will then be further processed into fuels which would produce fewer greenhouse gases than the traditional fossil fuels. As this is a new developing technique, understanding what is in these oils that are produced from the plastic waste pyrolysis is vital to understanding how they can be utilized as fuels in the future. One way to examine this is what we are trying to do using SFC and GCVUV. SFC, or supercritical fluid chromatography, is using carbon dioxide at its high density mobile phase, which displays both the properties of a gas and a liquid, allowing it to be a green analytical technique and being faster than traditional methods. While we don't normally associate carbon dioxide with being environmentally friendly, carbon dioxide is much more environmentally friendly than the other organic solvents that normal techniques use. Using SFC in the first dimension, or as the first separation, also allows easier collection of the analytes after it is gone through the instrument, as since the majority of the mobile phase is carbon dioxide, it goes into the air, leaving a more concentrated sample. Using GCVUV, or gas chromatography vacuum ultraviolet spectroscopy, we can have a universal detector that has a unique spectra for each compound. This will allow a library to be formed where you can identify all of the organic compounds that are in these oils. The reason why we are combining SFC and GC into this two-dimensional chromatography is it allows a greater peak capacity, or amount of analytes that we can see in a given separation space. The first step that we have done to approach this issue is we needed to find a good separation on the first dimension, or using SFC. Currently we are in the process of doing this, but one of the first things that we needed to find was the modifier, or the organic solvent that's going to be combined with the carbon dioxide to help the separation. As you see in this chromatogram, we found that acetonitrile was the best modifier, which makes sense as it is nonpolar compared to the others, and as we are dealing with a polar stationary phase and nonpolar analytes and a mobile phase, it helps enhance the separation. The columns that we noticed is that a 2-ethylpyridine column tends to be the best one, which was surprising as it is a more polar column than we thought, as the analytes are nonpolar. We then fractionated these compounds, and we need to understand how the fractionation works, so we used a tea mixture of caffeine and theobromine to try to get an understanding of how to create these fractions. We were able to do this, and you can see that we were able to separate caffeine and theobromine in certain fractions, but there is some carryover into additional fractions which we need to solve in the future. We then were able to take these fractions and put them on the GCVUV, and we were able to detect these analytes where it was a more simple mixture. While the first one is just a pure oil, we were able to see that on the third graph, the green chromatogram that you see, there is less sample, which will hopefully allow us to identify the compounds in these oils. In the future, we need to improve the fractionation, we need to improve the first dimensional separation, and we are hoping to get mass spectrometry involved so that we were able to identify and have more compounds identified and have a greater library. Thank you for your time.